Back to Michael.
Okay, so first of all, I just want to thank everybody for attending today. That you were here. These will also be posted online. So if you know anybody that wanted to come and wasn't able to be here, definitely get these off of the various channels and things that we will post it on. So we have it there. Also, very happy to follow up with anybody specifically afterwards about this. Uh, and then this is really a resource for you. So we're going to go through some just general slides, and then we'll have some time for some questions answered, free discussion to see how we can do this. This is your meeting as well, so definitely make sure that you ask anything you need, or make sure that we can follow up with you to get you any of the data that can help you out with this. So the focus on this is going to be a little bit different than, say, how do you write this specific grant, especially given the fact that, there's not really an active solicitation, especially in something like CC Star, where we had been, many of the people had been previously working through their grants. Uh, right now, we're in some very uncertain times, and we're trying to navigate a lot of that uncertainty. So the idea here is, you know, what can we be doing in general throughout our journeys with RCD and within our organizations to kind of make sure that we're ready for any opportunity that comes up. So these are more general guidelines, not specifically saying how to write an intellectual merit statement or a broader impact, but we can definitely get into those later on, especially if we get to times when there's an actual solicitation out that people are actively pursuing. So there we go. Okay, just a little bit about me. I'm the CISO and Senior Director of Infrastructure and Research Computing at the American Museum of Natural History in New York. Uh, I am the co-PI on now 4 successive CC Star Awards, starting a network, going through compute, then data storage, and then back to network campus for a continuing grant to expand our Science DMZ. If you want to click that QR code or scan it or whatever, that'll also give you my direct contact information that you can add there. And yes, in case you're wondering, it is literally 3 different types of jobs that I have. So, when everybody says we don't have any time for any of this stuff, we're all working multiple jobs. I'm there with you. I see it. I know it. I feel it. A little bit about the museum, because we're not your typical university or college that most people think of in this regard. We are a research facility, though. We were founded in 1869. We have a full-time scientific staff of 225 plus, give or take, research and research fellows, as well as students. We have a collection of 35 million specimens, and we do more than 120 special field expeditions a year. We're also a degree granting institution. We confer both PhDs and Masters of Applied Teaching in a couple of disciplines, very focused fellowship-based programs through the Richard Gilder Graduate School. So we're fully accredited and deal with, those same issues there. Just to give a little bit of background on the 4 awards, we have the 4 successive awards basically spaced out about a year and a half apart, depending on how it came. It started with the Science DMZ, then moved on to a compute award, and then moved again on to a storage specific award, and then back to the campus. The key thing I want to point out to everybody here is just one of the first things that we addressed when we started writing our grants a few years ago is if you notice the makeup of the PI teams. The senior leader of the technology infrastructure team at the museum, Juan Montez, our chief information officer, is the PI on the grants, on all 4 of them. On the other side of me, on these VBCs, are a researcher, curator. One of them was our provost, one of them was our dean of science. So they are direct scientific representatives in there. So what we wanted to do is make sure that this was not all IT focused or all research focused. So we built a collaborative team that had both IT representatives as well as research representatives. So everybody was kind of given an equal voice inside of that grant. And then in areas where it's very tech focused, Juan and I were taking the lead. In areas where the researchers need to understand, and how do we speak to them and how do we engage them, the research PI is really taking on that role. So it's been a very successful mix for us, and people feel that they're very adequately represented across there. So it's not just an all or nothing on one side or the other. All right, so just a little bit about it. When we first built this out, it was a Science DMZ. This really was providing the framework and the base of everything we built off of. Started out with a 10 gig connection to NiserNet or regional RNE, 10 to 40 gig internal connection, some data transfer nodes, very standard Science DMZ kind of a proposal. This was the foundation. Building onto that, then we built specifically compute services, uh, 22 traditional computing nodes, some high memory nodes, some GPU nodes, tied it into Open Science Grid, everything like that. Very open source in terms of the HPC tools. We also managed to slide in Fiona from the National Research Platform out of California, which is hosted here at the museum. Of course, nobody ever has enough storage, so the next grant that we did was Open Storage Network Pods. Gave us about 3.6 petabytes of total storage, to local, 720 of it was seeded to the OSN cloud. And then basically we could then use the other access, allocations through access and things like that. Worked with, iRods and Cloudera OSDF, some other areas to deal with some data management and access. And then now the Science DMZ, after we added all this stuff, was getting a little long in the tooth. So the goal there was to refresh this, bring it. We're now coming up to redundant 100 gig connections. We're reducing a lot of scientific bottlenecks and then consolidating our computational network. So the point of all of these is that this is a very planned out iteration from one step to the other. Where did we start? How do we build the foundation? How do we build onto that? How do we support it? How do we keep refreshing it? So it's a very planned kind of iterative approach to the grants that we pursue and how we deploy them. This is kind of where we were prior to the funding of the last grant that we got, the Science DMZ refresh. This is where we were planning on going. So it kind of breaks into three main areas, which is kind of the access type areas. It'll be the interface to a lot of our computational and Science DMZ based systems. And then we'll have a separate compute fabric on the back end to tie together all the computing nodes on the Science DMZ. So this is in process now. As soon as the equipment gets delivered, we'll be off to the races. All right. So the real question is, though, that's real great. Great that the museum did this. A lot of people are doing it, but hey, I'm just getting started, or I'm trying to expand my program or build it. It's kind of, where do I start? And if you look at all the materials out there, if you try searching out how to write all these grants, you're in for a real doozy. There's so much information, almost more than you can consume. So question is, how do you build it into key building blocks that you can work off of? And that's really the focus of what I'm looking at today. So the first building block that I always worked with, and this is how I started when we were bringing this program online in 2017, 2018 for the initial grant, was developing the external relationships. Long before I ever put any pen to paper, started developing any plans, things like that, I was starting to attend meetings. Meetings that, frankly, I was probably underqualified to be going to. Really spent the first probably one or two times at some of these meetings just trying to figure out the lay of the land and who the players were and where I could get some help. So it started out going to the Pacific Research Platform, which has now become the NRP, meetings that were out in Montana. Started going to some of the SC conferences, going to things with NiserNet, Globus, different places like that. Basically, anytime I could get to anything, virtually or otherwise, I tried to sit in on it and just absorb somewhat by osmosis what was going on, what people were doing, and the ways that they were focusing on that. This gave myself, my team, the general IT team here, some opportunities to network, build connections, understand who was out there that could help us. CARC was a huge opportunity for a lot of people, really great resource for people. If I can just be somewhat self-promotional here in terms of, the group that we're with today. But just in general, any opportunity that was out there, we kind of joined on it. It allowed our staff to kind of get trained, become qualified to execute the potential grant awards, because that is a key thing in the grant. Does the team that you're proposing to deploy the grant have the necessary tools, experience, and connections and resources to be able to do this? And on the initial grants, we relied on things that we had learned just by attending these meetings, but we very heavily leveraged guys from ESNet and Epic at the time. On the compute grant, we leveraged a lot of people from Open Science Grid and some other places that had done it. We had worked with Trusted CI to figure out how the security was going to work on these. So what we were able to say is we have some engagement here, we have technical capability on the ground, but we have resources that we're going to be able to pull from that are specifically experienced in the RCD environment and will be able to provide us that kind of supplemental help. So it was a way of both building the internal team and then building the external resources to help us kind of support those things and move on from there. The other thing about these meetings is it gives us insight and ideas that we may not have otherwise considered, and then figured out pitfalls to avoid. We have all walked face long into an issue that we weren't expecting. I am absolutely happy to let other people have experienced that pain before I get there. And you should definitely learn from any of the pain that we've gone through, the places we've made mistakes, because there's no need to keep repeating the same mistakes. So having these relationships is key, and we continue to try to develop them and maintain them, even in the face of a lot of changes that are going on, or funding changes, program changes. But the community and the people in it tend to stay the same, and they tend to be very welcoming. If you ask them, you say you need help. I've never had somebody say, nope, we're not going to be willing to do that. So this was the very, very first foundational block that we worked from. The second thing that we did is started trying to figure out, well, what are going to be the intellectual merits or the science drivers that we're going to be working with. This process started for us probably 4 or 5 years before we really put our first grant in. This was going out, talking to the researchers. Hey, what are you doing? What do you need? Looking at the grants that they were submitting that might have had cyber infrastructure or compute or something involved in it. And people were building various small HPCs or small computing environments kept underneath their desks. Just very ad hoc, inconsistently supported, and things like that. So by just seeing where they were going, offering them some help from central IT, we were able to just build some of those relationships. Even if it was just a matter of helping them with driver issues or software upgrades, whatever it might have been, just light engagement with them and really just figuring out where their needs were. The other part of it was we were figuring out what they were doing with it. And I am not an expert in any of the science that any of our researchers are doing, not by a long shot. I can give you a really rough idea of what magnetohydrodynamics might be, or how climate information is done. So much to write a paragraph, but just going to their talks and seeing the presentations they were putting out, including their student presentations, gave us a general sense of who was doing stuff. Oh, you're working on climate. Here's a climate specific grant, or here's where compute might be able to be used for some of these things. Have you thought about this? It kind of gave us like the external relationships, it gave us some kind of an internal roadmap to who to talk to, who to engage with. Also, just frankly, being present and visible and interested in what they were doing, and just not trying to dictate how they should do it, but just understand what they needed, allowed us to be, like government. We come from the government. We're here to help. We come from IT. We're here to help you build your system. Very few people want to hear that. But when we have a better understanding of what they're doing and they see that we're engaged in it, they were much more willing to say, oh, maybe you can help me with these things. The other thing is understanding where those opportunities for funding arise. They may not just be your standard CC stars that we've been doing, or MRIs or anything like that. There are multiple different opportunities, multiple different grant agencies that come up. Just having a directory of who's kind of doing what at a high level, uh, we know who can benefit from it, and then we were able to just direct engagement to them. Hey, this is something we can do. You have data transfer needs from what we understand. Um, Here's a grant that might be able to help us get stuff to help with data transfer. What do you think? Maybe something we can work on together? And that was how we built a lot of this. But we started building this foundation years in advance. And it just was an ongoing and still is an ongoing process. Broader impacts are a second building block. It's a key thing in all the grants and the current CC Star grants, as well as many other NSF grants. Uh, a lot of people, from what I've seen, actually treat broader impacts as kind of like an afterthought. It's a one or two paragraph thing to kind of check a box. I don't think about it like that. I think that there's a lot of opportunities in there to see um, outside of the direct scientific engagement, uh, what how does this benefit across the industry, the community, the school in general? How does it build the workforce? How does it help the country in general? And I've seen, especially in some smaller institutions, more emerging institutions, the broader impacts may have actually been weighed fairly significantly in the idea of their proposal. When I've been on certain panels reviewing these things, you look at it and say, okay, they may only have 4 or 5 researchers, but they have a ton of things that would benefit from broader impact. So that was something that could definitely weigh uh, a grant decision in their favor. The funny thing is, many of the things that started out as broader impacts for us actually ended up as science drivers. So, say on our recent storage grant, one of the things that we were doing is digitizing our entire collection. And so you're looking at that as maybe infrastructure, maybe some public engagement, some STEM education. But as it turns out, it was a key research function. It provides data that researchers are using all the time. So by originally having it as a broader impact, it actually became a key science driver for that grant. So sometimes the broader impacts, depending on what you're going after, could really be elevated to that more intellectual merit level. So that's why it's important to think about them and to record them and not just treat them as a secondary afterthought. So I keep a whole list of ongoing intellectual and science drivers that I come up with, talking to researchers that researchers bring to me. And we also look at broader impacts, like what's the institution trying to achieve? What's the country trying to achieve, and how do we fit those in? And that kind of becomes a grab bag that we build from. I'm a very big proponent of the cyber infrastructure plan, and the box up top is pulled directly from an NSF page, laying out all the things that they expect would be inside of a cyber infrastructure plan. But usually these things are only about 5 pages. So when you look at it alone, you're like, that's gonna be a 25, 30 page, document. Very well could be. Um, so I kind of keep 2 levels of ongoing cyber infrastructure plans, kind of a unrefined one, with as much detail as I need in it. So, what are the system architectures and what are the functions that we're dealing with? What are the data resources and services? That kind of rough draft version is usually 10 to 11 pages. Becomes our playbook as a new idea comes in, as a new cyber infrastructure element comes in, we add it in there. And then once a year, once every 18 months, definitely as a solicitation may be approaching, we go back to that larger growing document and refine it and kind of get it down to the 5 pages. It's usually required by the grant. It provides a guiding principle and for what we're doing with our cyber infrastructure program and our RCD program. It's kind of the goalpost that we're laying out, and it helps us align to both institutional and research initiatives as well as our capabilities and where the industry is. So, the keeping it sort of up to date and refined also provides a very strategic environment. I've used our rough CI plan in presentations to our board or in presentations to senior administration here at the institution, because we were able to pull those elements out and reuse them. And many of the things that we're proposing in here can be reutilized. So they're not wasted time and energy that we're putting in. They're really kind of foundational elements that can be applied in many different ways. So in terms of our scientific computing program, the CI plan is really our guiding principle. And then, to be honest with you, trying to write one and get it all into place when you got a solicitation bearing down on you is pretty rough. So we build off of it. One key resource that you should look at here is the ESNet has the CI plans posted at this link. Specifically for the museums, all of our published CI plans that we've used in grants are there and updated. So even the earlier ones, you can kind of see the progression on how it developed over 5-6 years. So I encourage everybody to take a look at all of those. They can give you some really good ideas. Here's another thing we do. Once or twice a year, we go through a mock build and budget. If we had funding today, if funding dropped in our lap today, what would we do with it? What would we need? If we try to answer that from the word go, here's 500,000, what do you want to do with it? We're often, trying to figure out, fighting off our back on it. But by building these mock builds and having them off to the side, having met with vendors and service providers and coming up with very high level draft designs and rough bombs that we would be using, it gives us a way of one, knowing how much this stuff is really going to cost, two, knowing what particular funding might be able to get us, usually more when we go out to bid and things like that than what we originally planned. But it also keeps us current on the technologies that are out there. And it means that if a solicitation comes out, we're already have the bomb partially designed, at least at a core level, and we have a rough idea of what the funding is. Usually what we do is we break those designs into 250 to 500K chunks. Usually the solicitations are somewhere around the 300,000 up to 700 to $1 million. So by breaking in those chunks, I just kind of can scale up and down as need be. The other thing that the mock builds are important for is looking at facilities. What do I need from power? What do I need from cooling? What are the things that the institution has to be able to provide? So it's often an afterthought. You get all this equipment, now you have no place to put it. So it allows us to engage and really figure out what's the facilities, the cooling, the power impacts that are going to be necessary. And sometimes then we may have to change what we would be planning on doing. Maybe looking at different cooling technology, maybe looking at hosting it someplace else that has better facilities for us to be able to do it because we can't support it in the building. For those of you that don't know the museum, we're landlocked on 4 square city blocks in Manhattan up by Central Park West. So there's no expansion here. We can't build like get an open field and expand the campus. The campus is what it is, and we have to fit everything in there. And so it's an interesting set of environmental challenges that we have to deal with. So those mock builds give us something else to work off of. And then the supplemental docs that we work through are often things that apply to non-infrastructure grants, data management plans, data sharing plans, facilities plans, what is available to researchers. So I get approached on a regular basis by our grant and our research proposers, current new PIs that'll say, I have to put these 3 statements in here. Do these look good? What I found early on was they kept pulling off of something that they had developed 10 years earlier, had no relevancy to what we were actually had available. So they're talking about old FTP sites. Now we have Globus data transfer nodes. They're talking about 2 gigs, 4 gigs to the internet. We have 10 and now an expanding amount of bandwidth capabilities to the internet too and other places. So one, it helps keep them up to date and makes their proposals and what they're putting into their proposals that may be non-CI related. kind of gives them the opportunity to have updated documents that go in there. It also gives us an opportunity to engage with them by providing them something that they can use, making their job easier, and gives us a sense of what they're proposing. Because usually what they'll do is they'll then send me a copy of whatever they submitted. And now I know kind of what they're thinking about, helps me build out new science drivers, and looking for opportunities for them. So having these in place makes it easier for everybody involved. All right, but we're here. So this is all great, but why do it without the funding? Okay, so now I know we tend to be very focused on NSF funding, and that's great. And God bless the NSF for being there and helping us so much over the last couple of years. But there are also alternate funding, and it's not just federal government. There are city and local funding, possibly non-governmental organizations that might be able to provide, or corporate opportunities that can provide some funding for these things. Maybe an alumni, any number of different donor opportunities. I am currently working on a bomb that is going to an alternate funding, non-federal funding opportunity for HPC. It will effectively double the size of what we built in our 2020 Mendel grant, the compute grant. And that opportunity came up very quickly. And in reality, it was nowhere near as complicated in terms of what we had to produce than what we would have had to do for an NSF grant. But the initial proposal, we had 5 days to build it. And we were able to go into this kind of grab bag of things that we've been maintaining, put it together over a weekend, and we were able to get it out there. It's now been, preliminary approved for funding. We're just going through some review opportunities and review processes, but we're very confident that it'll end up getting funded. So that's, not an opportunity that just came out of left field that we were ready for because we had been producing these things. Second thing is reducing our reaction time. Grants take time to write. None of us have a lot of time on our hands. Nobody's sitting there idly. The submission dates are never convenient. I don't care when they do them. They're always bad timing. So if you have the pieces partially drafted out or framed out, the workload is reduced. The effort is reduced. It's partially already written for you if you've kind of been diligent about doing these. Sometimes there are going to be shared opportunities that'll come up, regional, statewide grants, or sometimes there's an organization or a university, large R1, that might be anchoring a grant and looking for partners on the, smaller institutions and emerging institutions. Is a great opportunity. We should be ready for it. So this is why it's important to keep some of these things in the hopper. And then we're all too busy. This is really a question of eating the elephant. I try to set aside an hour to a week, ideally, to do RCD related development things and be ready for grants. It's a lot easier to do 1 to 2 hours a week over a year than 50 to 100 hours over a month. So that's the way we've been breaking this down a little bit. But I think that the key thing that I would say is, and really I think what has been part of our main success here at the museum has really been being ready for the opportunities that come up and being structured for those. So we're never kind of going from the word go. We're already sort of half written by the time the solicitation comes out, and always kind of planning for what the next thing is. So even after the Science DMZ grant, we have 2, 3, 4 ideas down the pipeline that we've been developing over time. And that's really how we've been focusing on it. And this can all be done when there's no active solicitation, no funding, uncertain economy, because this is brain work. It's some engagement, but I also find that the team likes working on it, and our researchers appreciate the fact that we're always looking out for them, which really helps us with that relationship. So at a very high level, that's kind of the strategy that we've been employing here to be ready for these grants. I'm very happy that we've gotten 4 successive, awards, and always some good feedback on them. So it's been a success for us. It's the way we've been attacking it. Different people may have some different ideas, so I'm more than happy to open it up to any questions, discussion, anything that anybody wants to ask about.
Best kind of presentation that validates my existing assumptions.
So, Michael, I had a couple things that I wanted to notice. I'm John Hicks from Internet 2, involved
Hey,
with
John, how
Clark.
are you?
Good, how are you?
I think I know we've met somewhere along the
Yeah,
way in person, but good to see you.
pretty sure. So on slide 20, you listed all the organizations that you sort of reached out to and tried to go, their conferences and get involved with. And I didn't notice Internet 2 in there. And I just offer that we do have two conferences a year, the
Mhm.
Technical Exchange, which is actually coming up in December this year, and we have a community exchange, which is more sort of sea level and that kind of thing. But there are some really good resources, and I've been running a BOF for regional networks interested in. I know this doesn't quite apply, but regional networks doing um, research. So the RCD side of how do regionals get involved and reach out to their constituency and things like that. So I would just suggest, looking at that or looking at our organization for other resources. And we're very keen on offering letters of collaboration when we can meet and actually do something. We used to sort of blanket that, but now we have to say sort of what specifically we're doing. And in a lot of cases, that's just providing a network or the backbone and that kind of thing. And that's usually fine. But that was just one thing. And the
Yeah,
other is, and I
just one
apologize.
thing, just John, really quickly, one thing that I would say, this is also an area. So just so everybody understands, our official RCD team is myself and like two other people. And so we're kind of burning, a lot of opportunity going to different places. One of the things that we did, John, you mentioned the regionals a lot, and this is one thing that I would suggest that people rely on is NiserNet, which is our local regional, as well as some other that we know, people from Edge and Kimber and things like that, Keystone Ren are very involved on the Internet 2 side. So we have actually relied on them to bring some of those learnings out to us because we just can't get to every conference we want to.
Mhm.
And so that's kind of where we break that up. We know that those guys are out there, they're heavily engaged, they're very engaged with the I2. So they provide a conduit of a lot of information back there too. So there's sometimes where we're getting a lot of the benefits that the Internet 2 is providing at all these meetings. I would love to get out to them as much as I could, but this is also where we rely on our RENs and others to help kind of spread that load, and they bring that stuff back to us. So
Yeah,
that's
great.
another
Great
way of
resource.
engaging for the things you can't get to.
Yeah, great resources. And the other thing, and again, I apologize if you talked about this, I had to step away for a minute, but are you familiar with the CARC capabilities model?
I am, yes, and I've been on many of the calls for those. I think it's again another part of what CARC can bring to this. Without getting into a lot of details on it here, there's definitely, opportunities for us to bring that to the fore through the various channels to people. And this is where the engagement with CARC brings a whole raft of other resources that people can become aware of. There's just too much to get into a
Sure,
one
no, I understand.
presentation.
But you did a lot of you've done a lot of work on the CI plans, and so while going through the model doesn't doesn't write it for you, it will bring up a lot of questions and capabilities that are considered mature or for a organization to have to support RCD. And so I would again suggest just kind of looking into that a little bit and going through that because it really folks are really finding it helpful to again do the CI plan, and it sort of exposes a lot of information about some things you may not have just thought about before or something like that. So again, just another resource to investigate if you're interested. So that was all.
Absolutely.
Thank you. Good talk though.
John from Fred Hutchinson. Did you have something?
Well, I just wanted to ask about your storage grant. Um, I found that it's quite difficult to find ways to fund storage in particular. It's much
Mhm.
easier to go for compute or networking. What was the solicitation number that you used for that grant?
It was,
That's the same CC star.
yeah, it was a CC star. It was one of the areas in the CC star, in 2018. If you want to look at, if you look up our, let me pull it up for you. Our the award number that we had on the storage grant was a CC Star storage grant, and it was I'll put it in the chat so you can do the award search. So you can see our abstract and our reports and things like that. But that was basically the inside the chat I posted there. It gives us and thanks, Dave. Dave Reddy posted the solicitation from the time, but that was the award that we used to get it. So you can kind of see what the solicitation was and how we apply.
Yeah. Now, at one time, John, there was not a storage CC star area. And they used to get a little bit punchy about your science DMZ proposals having a max percentage of storage cost into them for your data transfer nodes or whatever else you were talking about. That was, I'd say, generally alleviated when they added an extra area in CC Star that was devoted to storage.
Yeah, it's, for example, our recent S10 that we just managed to get funded. We're very proud of that. You're not allowed to spend any of those funds on actual storage. So it's
S10 is like completely compute focused, right?
yeah. So it's challenging to get the storage you need.
Yeah, and again, that was another thing where we were really starved for storage, to be honest with you. But so many of the lists that I keep, in OneNote and on SharePoint and things like that here at the museum is pretty much wish list of what we can do. I have no active way of getting it for you. I have no idea how I'm going to do it, but now I know that there's, oh, somebody needs this and this and this and this, and we could use, 10 petabytes of storage tomorrow if you gave it to us. But the knowing that and knowing who was suffering with a lack of storage meant the second that showed up in a solicitation, we could absolutely pivot to it rather than having to go back and say, okay, who needs storage and what and for why. We just have been collecting it. So I actually have a folder on one of my drives, which is just, unfunded, mandates, just wish list kind of stuff. And surprisingly, just, it sometimes appears when you're least expecting it. So just that readiness. Now, guys, I'm an old Boy Scout leader, so be prepared is kind of like my mantra. And that's really what I've been focusing on. Like, how do we just be ready for anything that comes out?
I think the other thing, then this plays right into your be ready mantra, which I completely agree with. Something that's very impactful to these awarding agencies is publications. And so it's really critical that from the beginning, you're telling all your researchers, please cite this award.
Yep.
Right? Because you want that big list of publications. Here's all the science that this award, that the previous award has helped produce.
Right.
And you don't want to wait until, 3 months before your deadline to actually start doing that, right? You need folks to, you want to do it from the beginning constantly so that it just becomes default nature to your researchers.
Yeah. And there have been some efforts to help people figure out how to get their facility, like a DOI or another persistent identifier that can be cited. Jason, is that part of what's coming up next month or next week or whatever in Campus Champions, or
Yeah, I
is that
believe
a
it
different
is
kind of?
actually. I
Okay.
think you're correct, and we're going to be talking about persistent identifiers, and there are other people who we could loop into that who have expertise directly in that.
Yeah, and one of the things we did is in kind of the statements we give, if you're using our computer or using our network or data transfer nodes or stuff like that, it's for any of your research. Once we give you access to it, we actually have a set statement that says, this XYZ research was supported by bing, 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 whatever it was, and the particular grant. So if you're using our storage, throw this in. If you're using our compute, throw that in. Everybody's using the network underneath it, so just that goes as a matter of course. And then yeah, we check in. Hey, how's your grant going? Everything like that. Any publication. So they send us those things. We collect those DOIs as examples of what they're producing with the work.
David, unmute, please.
Yep. So to a little bit to John's question, I don't know if you noticed on Mike's slide about the OSN pod that some percentage of the storage, I think it's about 10% or 15%, gets allocated to the open storage network.
It's 20. At least on the solicitation we did was 20 at the time.
20. Okay, 20. So yeah, 20% of 3 petabytes is, still a fair amount of storage, and everyone else who has an OSN pod is donating to the open storage network. And putting on my Campus Champions leadership team hat here, one of the probably lesser used things that's available under NSF Access is the open storage network. No, it's not going to be super performant, but it is definitely available and very easy to use in my uh, testing. So I have arranged for a test project out there, and I've hooked it up and used it with Globus and used it with CyberDuck and all these different tools. So one thing you could consider if you're having trouble getting storage is applying for allocations.
Yeah, and you don't have to have been a contributor to that, like Open Science Grid and other things like that, Open OS Pool. You don't have to be an active contributor to it, and it's not directly related to, okay, museum gave up 20% so they can get 720 terabytes of storage off of Access. It's there as a community service. So, we're all contributing into it, like some of these more distributed high throughput computing capabilities that are out there that people are very familiar with. So this is another opportunity where you can apply for that, and you don't necessarily have to have been a contributor to the underlying infrastructure. It's there for everybody to use.
Yeah.
And
I will,
by the way, I just
David.
want to mention, I also put in the chat the link to the research resource IDs. So we recently applied for our high performance computing team here at Research Computing for a research resource, an RRID, so that people can reference us and our group as an entity when they're doing their grant applications and writing their papers.
And though several people have already seen it, I left a link in the chat if you are going for NSF things that need the PATG document format. I have, I'll just screen share it real quick. I do have this NSF proposal GitHub repository that, again, I left in the chat. It supports pretty much every valid font that NSF will take, every valid font size, and it basically removes most of the need for fiddly little formatting that you would have to deal with. Should work in Overleaf, definitely works on regular tech installations. It is super compact for your people that want to pack in a ton of content and can't make it fit on the right page count. And there's a few other example pieces down through there of how we did some Gantt charts that's helpful. And then in some of the sample output, one thing that took a while to get the to get working correctly, but it is really impactful and really compact, is this sort of summary table that we did for a lot of our science drivers, where we could group them by sort of the same thrust and then have common attributes of how they were going to, be able to use things. I am a bit of a typography and, graphic presentation nerd. And so I fought real hard to try and get this as, as dense and as readable as possible on one of the grants that led to this. So I am now done with my shameless self-promotion, probably.
That's this is the key thing that's coming up. I mean, like this is exactly the kind of thing that we leveraged. David Reddy's known me a very, very, very long time. We both worked at the Museum of Natural History. So, if you had told me, or if you had told him that I would be involved in research computing, at the level that I am 25 years ago, he probably would have laughed. Because I was just a network jockey when we met years ago. I was building the museum network, and David was doing a lot of the scientific and research work here. It was very cool. So, it's great that we keep coming back together in these calls. But this is what's happening. The community out there is supporting each other. Somebody has probably already solved your problem, or at least can tell you how not to step into the bear trap. So the thing about it is, don't be afraid to ask. I love being the guy who knows the least in the room because that means I have the opportunity to learn the most.
And just for the record, I'm not the least bit surprised because anytime I needed something actually done, it was always Mike who did it. And I just hope he has a couple of mics in training working under him now at the
Yeah,
moment.
but none of them fit into the walls the same way I did, Dave. That's the thing. And if you ever get to New York, honestly, please come and visit us and see what we're doing here because you want to talk about doing something in a challenging environment physically. There's a lot crammed into this. We're the facilities equivalent of Mike Renfro's incredibly dense proposal documentation and typography. Speaking of incredibly dense, unfortunately, I need to run now halfway across the campus to get to a meeting that I already punted an hour from my boss, told him I can't be there. So he's going to start calling me in 2 minutes. So I'm going to run off, but Patrick Clemens, anybody, you have the contact information. I would be very happy, as I know anybody else in the community would be, to sit down. And if you want to deep dive into this stuff, John, you want to see what we did with OSN and how we put it together, give us a call. We'll get the engineers together and just bang away at it. You can see what we did and how it works and how it interacts with everything and then take it from there, man. And be happy to do that. Okay.
Thank you.
And if anybody else has any other questions, feel free to just email me or email the Emerging Centers, steering committee team, and we'll get you answers.
Great talk, Mike.
Thank you, guys. Appreciate it.